What types of loads cause bridge collapses? Have you ever wondered what really leads to a bridge collapse? It's a serious issue that can happen for several reasons. Understanding the types of loads that can cause these failures is essential for safety. Let's break it down. First, we have dead loads. These are the permanent weights of the bridge itself, including the structure and any fixed attachments. Engineers usually account for these loads during design. However, if materials deteriorate or defects occur, the bridge can become vulnerable. Next, we have live loads. These are the weights from vehicles, pedestrians, and trains that move across the bridge. When too many heavy trucks or traffic congestion occur, the bridge can experience excessive bending or shear forces, which may lead to failure. Environmental loads also play a significant role. Floods and hydraulic loads can erode the soil around bridge foundations, causing instability. In fact, floods are responsible for about half of all bridge failures. Strong winds can create lateral forces that lead to oscillations or buckling, especially during extreme weather events. Additionally, earthquakes generate dynamic forces that can exceed a bridge's capacity if it is not designed to withstand seismic activity. Impact loads are another concern. These sudden forces can come from collisions, like vehicles crashing into bridge supports or ships striking piers. Such impacts can cause immediate damage and initiate failure mechanisms. Thermal loads should not be overlooked either. Changes in temperature cause materials to expand and contract. If these movements are not properly accommodated, they can create stresses that weaken joints or supports over time. Lastly, fatigue loads arise from repeated traffic over the years. This cyclic loading can lead to material fatigue, resulting in cracks and eventual structural failure, particularly in steel or reinforced concrete bridges. Different types of structural failures can occur due to these loads. Flexural collapse happens when bending stresses exceed the capacity of beams. Shear collapse occurs when shear forces surpass the strength of components, particularly in heavily loaded sections. Buckling collapse is caused by compressive forces that make slender columns suddenly deform. Many bridge collapses result from a mix of load effects and human factors, such as design errors or lack of maintenance. Overloading from traffic is a frequent contributor, and environmental loads, especially floods, are common natural causes. Regular inspections and maintenance are vital to catch damage from fatigue or corrosion before it leads to failure. By understanding these load types and their effects, engineers can design safer bridges and implement preventive measures to avoid catastrophic failures.